Okay, so now we're going to put this stuff into action. We're going to do a problem, and the slides are going to be online, so you can look at the slides itself. You can always pause, rewind. You're going to take your answers to this problem, and you're going to put it on a piece of paper and eventually transfer into the Google form below. Okay? So, here's our deal. We've got our parallel circuit. Here are our new rules, different from series, and we're going to put them to use. Okay? We did a lab earlier today where we got some numbers. We noticed these patterns. We previous video explained these patterns. Now we're going to practice. Okay? So if I've got a 12-volt battery, a 6-ohm resistor, and a 3-ohm resistor, what we're going to do is we're going to use these rules to figure out the voltages in each part of the circuit, the current through each part of the circuit, and we're even going to test this idea with the resistance and the total resistance, especially practicing with this. Okay? So, first thing we're going to do is the easy stuff, all right? So we want to know what the voltage is across each of these resistors. That's the easy stuff because we're going to use this rule right here. Remember, here's our roller coaster. The height is our energy, so the energy supplied is equal to the energy used. If they all have the same heights, they all have the same energy. So that means if we know the potential here, we know the potential everywhere. So go ahead. Here's our potential from the battery. So we'll write down on a piece of paper the potential or difference, also known as voltage. So the voltage across each resistor. Go ahead, write it down. Use units as well. Go ahead and pause. Okay, so now we've got the voltage across here and here because we're using this rule real easy where the voltage being provided is 12 volts. Now we're going to figure out what the current is. We're going to use Ohm's law, okay? So remember, V equals IR. We know the voltage across here. We just found it. We know the resistance. That's a 6-ohm resistor if you can't see it. So the 6-ohm and the 3-ohm. So we know the resistance is 6 ohms. We know the voltage. We can solve for the current. So if I do my algebra, I would be equal to V over R, because that's what we're solving for. So you're going to substitute in for V1, you're going to substitute in your voltage, you're going to substitute in your resistance, and you're going to solve for the current in this branch of the circuit. So that means you'll know what your I1 is, and you're going to do the same thing, this voltage divided by this resistance, which is 3 ohms. So that voltage you found earlier, divided by this resistance of 3 ohms, gets you your I2, just using Ohm's law. Go ahead, pause. Make sure you have both of these with units for current. Okay, good. Like I said, you can rewind at any time, pause. All right, now let's get the total resistance for the circuit. So remember, the idea is for the total resistance is imagine we just have one battery and we replace the 2 resistors with one giant resistor, or one equivalent resistor. Okay? I'm sorry, before we get that, we actually have to get the current being provided by the battery. My mistake, got to do things in order. Good thing I rehearsed this. So, we're going to use our rule to get the current being provided by the battery. Okay? So remember, all the current that enters has to exit, or all the current that enters here has to exit. So if you know the current in these 2 branches, you can use the rule to get the current in this branch. So go ahead and get the current in that branch. Don't forget about units. Pause. Okay. So you've got the current being provided by our battery. So to get our total resistance, we know the voltage being provided by the battery. That's this thing up here. And we know the current being provided by the battery. We want the total resistance of the circuit. So keep in mind, Ohm's law, V equals IR. We know V from the battery. We know the current provided by the battery because we just figured that out. And we're solving for R. So I divide both sides by I. So I have V over I. So you're going to take that voltage, and you take that divided by the battery, and divide it by that current divided by the battery. And that will get you our total resistance of the circuit. Okay? So, we've pretty much got this thing solved. We've got the voltage across each part of the circuit. We've got the current through each part of the circuit. We've got the total current being provided. And we've got the total resistance of the circuit. The one thing I want to do last, and by the way, you can pause it if you haven't gone to that yet. Pause and get that with the right units. But what I want to do next, after you get that total resistance, is I want to check it with this equation, see if this works, okay? So if you haven't gotten this yet, pause it and get it. Okay, so now let's test this equation for the total resistance of the circuit. So I'm going to rewrite the equation on the next page. So 1 over the total resistance is 1 over R1 plus 1 over R2. Okay? So 1 over RT, and you can do this along with me on paper. Our R1, let me go back up for that again. That's 6 ohms, and our R2 is 3 ohms. So that would be 6 ohms plus 1 over 3 ohms. Okay? So this is where we're adding fractions. Remember, 1/6 plus 1/3 is not 1/9. It's not 2/9. We have to find our lowest common denominator. And for our lowest common denominator for this, 6, right? So I'm going to rewrite this as 1 over RT. By the way, notice I'm including the units for resistance, ohms, with it. So 1/3 becomes 2/6 of an ohm. Okay? So I'm going to let you take it over from here now that we've got it set up. You're going to add those two fractions, 1/6 plus 2/6, to get 1 over the total resistance. So you get a new fraction here. Now keep in mind, the units are on the downstairs. So we're not looking for 1 over the total resistance, we're looking for the total resistance. So the last thing you're going to do is you're going to flip that, so it's RT over 1, and that will move the units also flip to the upstairs. Take that number, reduce it, and see how it compares with what we calculated on the previous page, okay? So going back to this previous page, where you found that RT, see how that number compares with this number right here, okay? Great job. You can pause, you can rewind, you can go back to the previous video, and these slides I'm going to freeze and put on the wiki as well as PDF right below this video. And don't forget to fill out the form with your answers. Nice job.